All right, let's talk about a technology that you hear about everywhere but can feel intimidating. I'm talking about Kubernetes. Now, it sounds super complex, and honestly, it can be. But by the end of this, you're going to see it not as this confusing beast, but as a really clever solution to a massive problem. So let's just dive right in.
So, here's how we're going to break it all down. First, we've got to understand the why, what I'm calling the container chaos problem. Then, we'll meet our hero, Kubernetes, and see how it works using a really simple factory analogy. We'll look at the brains of the operation, the brawn, and finally, the things it actually builds. It's a straightforward path from total chaos to perfect control.
Okay, so first things first. Why do we even need Kubernetes? I mean, what's the point? To get that, you have to understand the world it was designed for, a world that runs on containers. So pretty much all modern apps these days get packaged up into these things we call containers. The easiest way to think about them is like little self-contained boxes. Inside each box, you've got your app and literally everything it needs to run. This is awesome because it makes them super portable. You can run the same box anywhere and it just works.
That sounds perfect, right? And for the most part, it is. But, and this is a huge but, it also creates a brand new, massive challenge, especially when you start to get popular.
Let's say you're just starting out. You've got, maybe 3 containers running your app. At this scale? Piece of cake. You can manage them by hand, no problem at all. You know exactly where each one is and what it's doing.
But then, boom, your app takes off. All of a sudden, you're not juggling 3 containers anymore, you're trying to manage 200. Now things are getting messy. Just keeping track of them all and making sure they're healthy is becoming a full-time job.
And then you hit that dream scenario, hypergrowth. You're now running 3,000 containers. At this point, managing them by hand isn't just difficult, it is physically impossible. You've officially entered what we call container chaos.
And this chaos isn't just a headache. It has real consequences. You can't possibly scale up fast enough when a huge traffic spike hits. If one of your servers dies, all the containers on it are just gone. Trying to update your app means taking pieces of it offline, which means your users see downtime. It is a total logistical nightmare.
This is the exact moment that Kubernetes walks onto the stage. It's the system that was built from the ground up to step into this mess, act like the boss, and bring some serious order to all of that chaos.
So at its heart, Kubernetes, or K8 as everyone calls it because it's just easier to say, is what's known as an orchestration system. It automates all that nightmare fuel we just talked about, deploying containers, scaling them up and down, and managing them. You know what? Just think of it as the operating system for the entire cloud.
Okay, to really get how Kubernetes works without our brains melting from all the technical terms, we're going to use a simple but really powerful analogy. Trust me, this is going to make it all click.
I want you to just picture Kubernetes as this incredibly advanced, fully automated factory. And this factory has one job and one job only: to build and run your application 24/7 without any humans needing to get involved.
Now, like any good factory, this one has 2 main parts. You've got the brains. This is the manager's office where all the big decisions get made. In Kubernetes speak, we call this the control plane. And then you've got the brawn. This is the factory floor where all the actual work gets done. We call these the worker nodes.
Let's start upstairs in the manager's office. The control plane is super important, but it doesn't actually run any of your app's containers itself. Nope. Its job is purely to manage the whole factory. So who's on this management team?
Well, first up, you've got the API server. Think of this as the front desk. Every single command, every request, every little thing you want to do has to go through here. Then there's etcd. This is the factory's long-term memory. It knows the state of everything, what's running where, which machines are available. It's the ultimate source of truth. Next is the scheduler. This is the master planner. It sees a new job come in and instantly figures out the best worker on the factory floor to handle it. And finally, you have the controller manager. This is the tireless supervisor who is constantly, and I mean constantly, checking to make sure that how the factory is running right now matches the plan you gave it.
Okay, so that's the management team in the office. Pretty smart, right? Now let's head down to the factory floor, the worker nodes. These are the actual machines, whether they're real physical servers or virtual ones, that are doing all the heavy lifting and running your application containers.
So on every single one of these worker machines, you've got a few key players. There's the kubelet, which is like the local foreman on that specific machine. It gets its orders from the big boss, the API server, and makes sure the right containers are up and running. Then you have the container runtime. This is the engine itself, something like Docker that actually does the work of running the container. And finally, there's the kube proxy. This is the network guru that handles all the complicated wiring so that all the containers can talk to each other and, the rest of the world.
So we've met the managers and we've met the workers on the floor. But what are they actually making? What are the products that this factory is producing? In Kubernetes, we call these things objects.
Let's see how these map to our factory. The smallest, most basic thing is a pod. You can just think of this as a single worker doing a single job. Then you've got a deployment, which is kind of like the HR manager. You just tell it, hey, I need 3 copies of this worker running at all times. And HR makes sure that always happens. A service is like the internal reception desk. It gives other parts of your app a single, stable phone number to call to find those workers. And lastly, ingress is the main security gate at the front of the factory, controlling exactly who and what gets to come in from the outside world.
And look at this table just puts it all together perfectly. You can see how the pod is the worker, the deployment is HR, the API server is the front desk. This factory model is such a powerful way to get a mental map of how all these complicated bits and pieces fit together to make one seamless, automated machine.
So here's the absolute key takeaway. Kubernetes isn't just about running containers. No way. It's the intelligent boss that figures out the best place for them to run, automatically knows what to do if one of them crashes, and magically updates them all without your users ever even noticing a hiccup.
And that right there leads directly to the real-world superpowers you get from this. You get automatic scaling, so when you get that huge traffic spike, the system just handles it. You get self-healing, which means when something breaks, the system just fixes itself. You can do complex application updates with 0 downtime, and because it's all built on containers, your whole setup is portable. You can pick it up and move it to a different cloud provider if you want. So what Kubernetes really does, when you boil it all down, is it takes that initial, terrifying state of container chaos and transforms it into this incredibly efficient, smart, and totally automated factory that can run any modern application at any scale. Which really just leaves us with one final big question to think about. As more and more of our digital world gets built on this model of containers and automation, you kind of have to ask, is this factory building the actual foundation for the future of the internet? Something to chew on. Thanks for tuning in.